Hello everybody, welcome to this vlog. My name is Satya. Today I will be discussing about VPRN, which is called as Virtual Private Routed Network. Right, so let us start looking at the topology diagram that I've shared. So we have two sites, one is customer A and customer B, three sites and customer C, right? So a route distinguisher identifies what is the type of routing instance that we have on each customer network. So customer A has a VPRN instance of 100, a route distinguisher as 65,000 colon 100. Customer B has VPRN instance 200, route distinguisher 65,000 200. Customer C has VPRN instance 300, route distinguisher 65,000 colon 300. Now to describe here what exactly the customer A comprises of is site A1, site A2, site A3. This is a customer edge equipment like what broadband routers that we use at home. These will be classified as CA1, CA2 and CA3. These connect to the different provider edge networks with the VPRN 100, right, through eBGP and IGP, interior gateway protocol. I've already prepared videos or vlogs where I explained what is eBGP and what is IGP. eBGP is also a routing protocol. IBGP is like OSPF, ISIS, etc., etc., etc. So using these routing protocols, we reach P1, P2 or P3 with a VPN instance 100, and there will be a virtual router forwarding instances which are all defined as VRF 100, right, where the routing instances are defined. So what is the main advantage of VPRN is VPRN is a layer 3 service network or a layer 3 VPN network. So each customer will have a unique IP addresses or overlapping IP addresses per VPRN, right? So for example, site A1 as is connected to VPRN 100, but it is having virtual routing router forwarding table 100, where all the routing entries which will be shared across different instances will be used, right? So let's suppose you are sending a packet from 10110 through the eBGP and IBGP. They reach VPRN 100, which has VRF 100 instance. There the routing table is made in such a way that 10110 does not overlap with 10120 of CA2 or PE2 like this. So you can have overlapping IP addresses on the same on the provider edge routers, right? So now once the packet arrives at VPRN 100, after checking VRF, it will route the packets to the P provider network. Inside the provider network, you will have MPLS based routing. Label switched network will be created between all the provider networks, and then again it will be using eBGP to connect to P4, P5, P6, P7, P8, right? There VPRN 200 will be defined. So whichever is the destination address will be sent to the CEB1, CEB2, CEB3, CEC1, CEC2, right? So all these 10110, 10112, 10113, these are all private network addresses specific to customer equipment A1, right? So once through eBGP or IBGP, these uh, packets arrive using the BGP routing methods or IGP routing methods of VPRN 100, it will check the VRF 100 and route the packet accordingly to the provider. Provider uses label switching to forward the packet inside the MPLS network and finally arrive at PE4 and then site B1, for example. So what are the benefits of having VPRN? As I told, VPRN can have overlapping IP addresses with a separate VRF for each routing instances that is defined for a particular VRF. Separate routing table VRF, unique route distinguisher RD, isolated customer routes, overlapping IP supported, private routed connectivity, right? So I hope this is clear to you. If you're not clear about anything in this diagram, or if you want to understand how the packet gets routed from site A1 to P1, then from P1 to P inside the MPLS network, and then from P to P4, P5, P6, P7, P8, and then to the customer edge boxes. Then please put a comment. I will try to explain with an example. Okay. Thank you. Bye.